Hello everyone, my name is Shashank Shetty and today I will be presenting my research on optimizing energy price forecasting with hybrid deep learning. Let me share my screen and show you the dataset and the code. Yeah, I have to included two data sets, the energy data set and the weather data set. In the energy data set, I include the energy records from 2015 to 2018, where the generation source like how much renewable and how much non-renewable sources were used while generating the electricity during that hour, and what was the load, electric load, and what was the total price and the actual price during the period. And I've also included the weather data set for on the Madrid city between 2015 to 2018. What was the temperature during that period and other details and the wind speed, etc. And I will be comparing these models with traditional deep learning models for forecasting energy prices, which are GRU and LSTM. Here, I have imported all the necessary libraries. When I have loaded the data sets, the energy data set and the weather data set, I have taken the data only for Madrid city and also removed the irrelevant columns, like which are null or have zero values. And I found, like while checking the duplicates, I found that the data set has duplicate values, whereas energy data set doesn't have any duplicate values. So I have, like, for the safer side, I have performed the drop the duplicate values of both the data sets. Here are all the columns in energy data set. Yeah, and there are a total of 35,064 records in both the data set. And in the weather data set, there were few columns which are in IIT, so I've converted them to float for the analysis. I've merged the two data set, energy data set and weather data set based on perform the inner join or based on time and dt.iso. Then I performed the feature engineering, like calculating the hours, what was the day of the week, what was the month, and is it a weekend or not, to find the seasonal change in the energy price. Then I also try to include the economic factor in the data set, like by calculating the monthly bill and what was that current month bill and what was the previous month bill during that period. I'll show you. Yeah, this was the current month bill during that period, and this was the previous month bill. I also draw the correlation heat map for all the features. And I have to find I perform the analysis. It was found that the electricity bill energy prices were lowest between the early morning hours between 2 to 4 a.m. and it increased during the in the morning hours between 8 to 9 a.m. and it was highest in the evening hours. And of all the generation sources, the more like 38.9% was renewable and 61.1% was non-renewable. Uh, and it was while plotting the graph with of time price versus temperature. Temperature doesn't have much effect on the energy prices, while wind speed has the reverse effect. Like if the wind speed is more, the energy price is less, as the wind is the cheaper source of energy. Yeah, these are the traditional models. The LSTM and GRU. I've added two layers for each, like with 50 filters, and the dropout was 0.3%. And I've used Adam Optimizer. The models were overfitted, so I changed the learning rate to 0.001 and increased the dropout. And also try to reduce the batch size and add early stoppage. Yeah, for the LSTM, I got RMSE of 5.99 or MEA and 4.47. And for the GRU, the RMSE score of 5.75 and the MEA was 4.28. Like while performing the and like applying the so CNN by LSTM model, I performed this like I performed min-max scaling and after that PCA for dimension reduction of 95% with random state of 42. Yeah, yeah, my CNN by LSTM hybrid models includes one convolution layer and one LSTM layer with 32 filters each, and I have used Adam Optimizer. It's here also the models were fitted, so I try to increase the dropout, set learning rate to 0.001 and add early stoppage and reduce the batch size to 16. Before I set it to 64. After performing, I got the MEA of 4.10 and RMIC of 5.18. This is the comparison between all the models. RSCNN by LSTM has lowest RMSC, whereas GRU was the second, and the worst performing model was LSTM. Thank you.